Hello. Today we're looking at the Blender source code. I have their git t instance pulled up. It's at projects.blender.org/blender/blender. They also have a mirror GitHub, but I assume this is where their developers hang out, so I figured I would check this thing out. Right? So Blender, for those who don't know, it's a 3D they call it a 3D creation suite. You can use it to create 3D models, to animate those models. They made back in the day, the Blender people made a whole film using Blender, and I believe they've also made a video game or two. They seem very serious about making a great project, and they're using they're using the creation of movies and video games as a way of eating their own dog food and making sure that they use the Blender tooling in anger, as it were, in the course of trying to get actually something done. And I have a lot of respect for that. One gets the feeling that a lot of open source projects don't do that sort of thing. There are a lot of open source projects um, where it's not quite clear that anyone has really used all of the features after they develop them. So that's really great to see. Um, so and as far as language, I believe it's written in either C or C++, and then they use Python for scripting. So we saw in Scum VM they used Lua for scripting. Lua is a very common embedded scripting language for games. And we saw in yesterday in the Godot engine that Godot uses their own custom GD script, the language that they wrote, designed, and implemented. Um, and it's typical for these 3D authoring tools and especially game engines to have a way of scripting the assets and the resources that doesn't require uh, going down and implementing in C++. So we may see some of that. So in their Git repo, everything seems pretty clear what it is, which is nice to see. There's not a whole lot going on. So source and tests, I think, are worth looking at. I'll look at tests first, and maybe tools. Let's see how far that gets us. All right. So in tests, we've got Blender as Python module. G tests performance in Python. Take a look at performance, API and tests, do tests, oh, cycles. How about geometry nodes? So first, I just want to get a sense of how big is this test. There's not a lot. We don't seem to be importing a testing framework. We're going to import API and OS and import BPy. I think that might be Blender, the Blender Python module. We'll evaluate something. Evaluate objects once first to avoid any possible lazy evaluation later. Okay. Set some measurement variables, timeout. While true, we're going to tag all objects with geometry node modifiers to be recalculated. Loop. Modifier type is equal to node. We're going to update tag. We're going to calculate. We're going to record start time. Do some updating. For elapsed time. I guess check how. That's a fairly minor test. Animation.py. Again, relatively simple. I don't know what it's reading from. So wait, let's see. Maybe you can run this on any file. So we're going to import BPy and time and API and OS. Start time, BPy context.scene. And maybe that's dependent on your Blender project, perhaps. Take a look at Blender as Python module. Also, what's G? Runner testing. Mock log testing.h testing main.cc. So the test assets directory is lib/tests from subversion, getting test assets. I wonder if they used subversion at one point before they moved to Git. And then the test release directory is bin/blender version. So we're going to fail if there's no assets directory, or rather if it's empty. Similar with the release directory. And in main, we're going to mem use guarded allocator, mem init, mem link detect, mem enable fail on mem leak. And we're going to init Google test. I guess they must be using Abseil or something, which is the Google testing framework that has a Python version. And we're going to call Blender dflags namespace parse command line flags. We're going to Google init Google logging, and then we're going to run all the tests. So, oh, sorry, this isn't Python. So the G test, the Google testing is presumably is Abseil, but the C++. Let's look at testing.h. Import G flags and import G. I'm not sure what gtest is. Maybe that's an older version. Google test is Google's C++ testing and mocking framework. Curious to see how it's related to apps. Abseil as dependency of Google test. I read that you plan to take a dependency on Abseil, and I wonder what this means exactly means. 2020. Well, seems like they're urging them or whatever. I think internally everything is Google is Abseil. All right, let's see. So here at Blender tests, we've got some define expect v3 near. There's some macros. V3 near. I don't know what this means. Maybe this maybe I don't know what V3 means. I don't think it's a three-dimensional vector because we've only got. Oh yeah, we are. I guess we're gonna test A and B. I guess within epsilon. And that's gonna do kind of. When you have floats, you can't really test for equality. You just test whether they're close enough. Expect matrix near. Going to check whether the dimensions match. I guess rows must be the number of rows. Yeah, okay. So if the bool dims match is equal to this, we're going to expect EQ here and here. And then if dims match, we're going to iterate over the rows and columns and do expect near matrix entry by matrix entry. So I wonder why if we can fail here, I don't remember whether this is going to continue with the test. I'm wondering why we compute this dims match and then we don't use it here. Like if we're down here, it seems like dims necessarily match unless these tests don't exit the. Okay, so this is some. These are some test utilities, templates. I'm not sure how they decided when to use templates. Lines. Okay. All right. So here's all right. So that was a quick look at tests. Let's take a quick look at tools. We can check Blender release, check source, check wiki, big Git modules, subversion revision map, utils, utils API, utils build, utils doc, utils IDE creator, maintenance. And these are the Blender dev tools. This repository is intended for miscellaneous tools, utilities, configurations, and anything that helps with Blender development aren't directly related to Blender. Some of the tools included may be used standalone. Others expect Blender's source code to be available. Okay, that's relatively straight. So here's Blender. Blender slash source slash Blender. And this rather larger directory. We've got the asset system, blend thumb, which is maybe blend font, blend kernel, blend lib, blend loader, blend translation, BMesh, compositor, data talk, depth graph, draw, editors, freestyle, functions, geometry, G-pencil modifiers, GPU, IK plugin, imbuff, might be an image buffer, IO, good output, makes DNA, makes RNA, modifiers. Let's look at DNA and RNA. Is that some sort of joke or pun? Modifiers, nodes, Python, render, sequencer, shader effects, simulation, and window management. Okay. I do want to look at simulation. And I'm going to pull out blender.main and I'm going to have I'm going to try two windows today. I'm going to try one which is the more serious core stuff, and one which is just kind of curiosity driven. So I'm going to guess that geometry and mesh are pretty important, as are lib and kernel in the asset system and the compositor. Depth graph might be interesting. Draw might be interesting. I'll skip editors and function. They already open nodes. I want nodes. Curious about Python. Sequencer, shader effect. Okay, so we'll come back to those. Come back to those more serious things in a bit. Now we're looking at makes RNA. We've got intern and RNA cleanup. What happens if I look at CMakes list? RNA types. User define instead of pragma once because BK add-on and some stuff. So we've got blender RNA, function RNA, pointer. RNA pointers are not a single C pointer. Include the type and a pointer to the ID struct that owns the struct. Since in some cases, this information is needed to correctly get or set the properties and validate them. We've got a struct pointer RNA. It's got an ID and struct RNA. Property pointer RNA has a pointer RNA pointer and a property RNA struct. Property types, you've got Boolean, int, float, string, enum, pointer, collection. Property unit, none, length, area, volume, mass. These are physics things. Property types are C++, not C++, programming language type. Still don't know what an RNA is. Here's property subtype. We've got prop none, prop file path, pure path, absolute distance, axis angle, Euler. Are these for assets? We have strings, numbers. Numbers include things like pixels, percentage, factor, angle, time. Booleans is prop layer member. Light is power. These seem like properties of an asset or a mesh, maybe. Enum flags, thick wrap, no delegate, property override flag. I have no idea still what RNA is. Let's take a look at makes DNA. DNA color types, DNA curves, DNA fluid types, DNA LNA, DNA NLA types, session and UID types, speaker types, text types, U3D enums, world type, DNA defs, DNA ID. It makes DNA.c. Makes DNA creates a .c file with a long string of numbers that encode the Blender file format. It is fast because it is basically a binary dump. There are some details to mind when reconstructing this file, endianness and byte alignment. This little program scans all structs that need to be serialized and determines the names and types of all members, calculates how much memory on disk or in RAM is needed to store that struct, and the offsets for reaching a particular one. The facility to get verbose output from SDNA. Search for debug SDNA. This can be set to 0. Hint, higher numbers give more output. This again makes DNA, creates a .c file. So C source file, the long string of numbers that encode the Blender file format. It is fast because it is basically a binary dump. C file is fast, or the code inside the C creates it. So this file is going to create another program, and that program has numbers, and those numbers encode the file format. Fast because it's a binary dump. What is fast? The file format is fast? Because it sounds like it's talking about the C file being fast. Maybe we can look at the implementation, but at least we have a code comment to help orient us. Let's see if RNA is going to give us sort of code comment looking into RNA. Where was I looking here? Make DNA. Is there a make RNA? That's makes RNA. That's RNA action. Void cat file cloth curves. About RNA main.c. All the list begin functions are added manually here. What this file or directory. Okay, so let's look at makes DNA. File name max. Got some mem area. Struct lengths, list of names, hash struct map alien static, debug printf stuff, add types, add names, calculate struct sizes, match identifier. Or it seems like what the comment is trying to say is that this is like code generation or somehow creating a Blender file. Let's just try doing a search I know that DuckDuckGo will just ignore my search. Source architecture RNA. Documentation on the implementation of the data API. Doesn't exist. Let's try searching here. Architecture. This is documentation on the implementation of the data. The implementation is in the makes RNA module. The important files to understand RNA types, the important RNA struct. Here, access, finding structs and property, DNA matching. Each property, we start with an RNA def property. Identifier must be specified similar to a struct. Next, we have to define a type and a subtype. Type defines the data type. Subtype gives some interpretation of the data. For example, float array property may be a color or a vector of a matrix. Again, the system will try to find a property with the same name as the identifier in the DNA struct. As a different name, the next thing to do is to specify it with RNA def star as DNA function. This DNA information is used to derive various things like get set functions or iterators for collections, array length limits, etc. What is it actually? What is it doing? What's the design of this thing? Any better sources? Isn't RNA or DNA examples? Blender, also in Blender. DNA and RNA are terms used by the Blender devs and community to refer to their system of serializing Blender state data, which is as old as Blender itself. Each .blend file includes a DNA structure. Details pretty much everything about the blend and about the version and exact copy of Blender last work on it. This makes Blender files highly backward compatible. They allow any future version of Blender to configure itself the same way older version would have been older files to digest the files in an extremely normalized way can be extended version to version without changing structure. RNA is a new concept. Think of it as a DTO, data transfer object for DNA. It allows pieces and subtrees of DNA to be passed around in Blender and between Blender and its plugins. Primary language for the Python. Primary way this is done. A short primer. Okay. Here's an interesting look into both Blender's path and future. DNA and RNA actually stand for it. And along for the biological meaning. DNA is a long string with encoded types, the entire structure of Blender's data, saved in every .blend file. Entire internal structure. I guess the idea is that they're fundamentally dumping memory. With this DNA, it can render older or even newer files. Blender is even aware of its own data types. You give it a pointer and Blender can find the item named vertex in it. Makes .blend files still readable even when saved in 1.0. And RNA, 2.50 feature, system to wrap DNA into a nice API and read set Blender data and properties. It actually means messenger DNA. Not totally correct because RNA makes DNA in cells. RNA can auto-generate a Python data access API and will allow everything animatable auto button lists to data and will even handle dependency. A lot of educated engineers hate this DNA. That's why all rumor and past to replace it with XML. A lot of educated. There's still people who think XML is superior. The funny thing is that Google, for all internal development, replaced XML, similar DNA system. I've never heard of this. This is from 2008. Drop human readability of the files. have the same flexibility and a lot more. I've never heard of anything like this. Okay, so they've got some complicated system for dumping memory to files. I'm not sure how this is supposed to make backward compatibility easier. Seems like backward compatibility is just now expressible in this system. Because ultimately, like if you change the implementation of a shader, then you're going to have to keep that old implementation around. It doesn't really matter how you stored the struct. Like you could, um, maybe that what they're trying to say is proto buffers. Maybe that's what they mean by Google having a similar thing. But sure, you could store messages in protocol buffers, which are like you can think of it as like a nicer version than JSON. They have versions. You can always read the older protobuf versions or whatever, but you're still going to have to keep around like the old implementations of those files or whatever. You're still going to have to be code that handles quirks for old files. I'm not sure what this is trying to solve. Like, seems like, yeah, if you want to write binary data files, that's fine. But I don't know. I don't have a sense of like what this is supposed to add on top of just writing it in a format like JSON. Okay, that's DNA and RNA. It's doing some sort of um, sounds like it's doing code generation for saving files. And I'm going to guess that what that blog post meant is protocol buffers because there is a code generation aspect there, but I'm not quite sure, and that doesn't really seem similar to RNA and DNA. Maybe if a Blender developer ever watches this, they can set me right. Don't get something that's complicated unless I think people really like it. So I'm going to assume that this is somehow nice to use compared to what some of the other alternatives. So if somebody has used it and wants to sing its praises, maybe they can let me in a comment or whatever. Okay, so where was I? That was DNA and RNA. Was there anything else just for fun that I wanted to look at? I said, let's see what blend thumb is. I guess that's it. That's source. Blend thumbnailer. Okay. Yeah, thumbnail. Cool. Very, very cool. Okay, now we're in source slash main slash source slash blender. Here's geometry. We can add curves on mesh. Add curves on mesh. I'm guessing it means add curves to a mesh, unless it has an algebra of curves. Sometimes you can add curves together. I don't think that means add curves on mesh inputs. We've got UV coordinates, which the new curve should be added. Determines the shape of the new curves, and we've got interpolate length, interpolate shape. So these are just booleans describing whether we should do these information about the surface that the new curves can be attached to. We've got a const mesh surface, a span m loop try, surface loop try. Not sure what span is. Span, float, corner, normals. Realize span. We've got a KD tree that contains the roots of the existing curves, only necessary when interpolation is used. Add curves on mesh outputs, and compute surface point normal. Generate new curves on a mesh surface to given inputs. It looks like they're adding curves to a surface. which is the more expected thing than trying to have a algebra of curve, which you can do, but I wouldn't really expect that in 3D software. Okay, so mesh to curve, mesh to volume, point merged by distance realize instances, resample curves, reverse UV sampler, set curve type, subdivide curves, subdivide, UV parameterization, UV parameterizer. So here's geo mesh to curve. And for some of these geometry files, I'm just mildly curious about the sorts of things they do. I'm not really looking to understand the logic yet. Okay, so we've got curve geometry, mesh to curve convert. You're going to pass in a mesh, in a selection, which is a type index mask, and propagation info, anonymous attribute propagation info. Convert the mesh into one or many polycurves. Since curves cannot have branches, intersections of more than 3 edges will become breaks in curves. Attributes that are not built in on meshes, not curves, are translated to the result curve. Create curve from vert indices. And to do that, we pass in a mesh, some vert indices, curve offsets, cyclic curves, and more propagation info. I'm curious what propagation info. I don't know if I'm curious enough to try to hunt down that file. Okay, geo mesh to volume. Let's see. A BLI function ref.hh, mesh to volume resolution. I got distracted for a second there. Okay, so geo mesh to volume. So what do we expect this to be? So we've got a mesh and we're going to convert it to a volume. So this could mean a couple of things. It could, on the one hand, it could mean that we're computing a volume from the mesh. Like if we had a parallelepiped that represented by a matrix, we could compute a determinant. That's a volume, kind of like a metric entity. It's a map into the real numbers. Or it could mean volume in the sense that like we've got a mesh and we're going to turn it into a 3D object that is maybe understandable by a graphics card or some other system. So let's figure out what they're doing. They've got a mesh to volume resolution of voxel size and amount. So it seems like maybe they're going to convert it to something. They're taking a mesh and converting it into like a volume in the sense of 3D shape. They return the bounds of the mesh positions used for deciding the voxel size in the amount mode. Volume compute voxel size. We're going to take what? We're going to take depth graph, which probably a dependency graph, maybe sub meshes or something. Probably not super meshes. We've got a bounds function that'll somehow compute bounds. Pass in an rmin and an rmax. No, it's going to, I guess, turn that. I'm not sure. Mesh to volume resolution, some sort of resolution, exterior bandwidth, and a transform. A float 4x4, which I'm guessing is a 4x4 matrix. We're going to add a new volume grid to the volume by converting the supplied mesh. And that's it. I'm not positive what that does. Do I have a CC? No, the CC file seemed to be somewhere else. Maybe they're an intern. Mesh primitive cuboid, mesh merged by distance, resample curve. Do you have volume in here? Mesh to volume, yeah. What do we import? We're including the header file. We've got mesh and we've got volume. BKE volume. We're in geo. Look at for BKE volume. Just so we know what a volume is. So BKE, what do we think that is? Blender kernel? Blender kernel. Got a K in it. And an E after the K. Yeah, look at that. All right. GKE volume. Guess I should just know my alphabet. Scroll to the bottom of the page. Here's the header file for volume. Got a bounding box, a depth graph, draw cache, grids. For volumes referencing a file, the list of grids and metadata must be loaded. Volume load. Yeah, so this is, I think this is a 3-dimensional object. Intern. Hey, we're starting with C. We not have the BKE prefix here. We've got volume.cc though. Global volume file cache. File cache? A volume. Tell me what a volume is. A volume grid. A volume grid is a wrapper around OpenVDB grid. Okay. See how many times does OpenVDB appear on this page? 137. Okay. So let's try looking up OpenVDB. Was it VDB? OpenVDB. Open source library for working with sparse volumetric data. Provides a hierarchical data structure, related functions to help with calculating volumetric effects in CGI applications. Cool. Academy Software Foundation. Like the Academy, Awards Academy, film people. Yep, and I bet that this is where the volumes are really defined. Okay, but now I need to know who the Academy Software Foundation. Increase the quality and quantity of contributions to the content creation industry's open source software base. Yeah. So who is this? Is this actually the Academy, or is it, or did they just like to name themselves that? Supported by the Academy of Motion Picture Arts and Sciences. Cool. I mean, this is a good idea, right? So there's this old article on commoditize your compliments. I think it's a Joel Spolsky. Wern. Yes. And the idea is that, like, you know, one of the reasons that open source software gets good is that essentially there's an economic need for it, right? So the Academy of Motion Pictures Arts and Sciences has a need for inexpensive software for creating 3D things, and they want that software to be good and easy to use, and so they're going to support like these open source projects that do things like how, you know, what was it, OpenVDB is relatively low level. This is a volume format. So if they support this, which is, they probably don't have to spend a lot of money to support it, then that means that lots of software will add support for this. And that means that software like Blender will be able to make their open source software, and they can build off of that and get good. And that's going to make it easier for the industry because they won't be as locked into whatever the proprietary 3D modeling packages like to do. Like I think Maya 3D is one that was used for a long time. I don't know if it's still one of the industry standards, but you can imagine if there's a handful of players like that, then that's harder for the motion picture industry because then they kind of have to cater to the tools that are available. Whereas with a system like this, they can try to encourage more of a proliferation of a more diverse set of tools, and that can help create an ecosystem where things thrive. So yeah, I think that's interesting. I think that's a nice alignment of the incentive. All right, so where are we? So we can subdivide curves.hh. We're going to add more points along each segment, with the amount of points to add in each segment described by the cuts input. So subdivide curves. index mask selection, and we've got an array of cuts, which are ints. That's that. The amount of points to add in each segment are described by the cuts. So I'm guessing, yeah, they're going to be equidistant in parameter space, but not in the actual distance. New points are equidistant in parameter space. So we've got some parameter space. And the easiest thing to do, and really the only thing you can do if you're just given the number of cuts to make, is to make equidistant cuts. But that's in parameter space because that's where it's easy to compute. And that may not line up with the actual distance. They just decide that's good enough. Sounds good. I mean, that's totally reasonable. Okay. Here's geometry UV parameterization. UV parameterizer. Got chart construction. Faces and seams may only be added between geometry UV parameterizer construct begin and construct end. The pointers to co and UV are stored rather than being copied. Vertices are implicitly created. In geometry UV parameterizer construct end, the mesh will be split up according to the seams. The resulting charts must be manifold, connected, and open. At least one boundary loop. The output will be written to the UV pointers. Least squares, conformal maps. Charts with less than 2 pinned vertices are assigned 2 pins. LSCM is divided into 3 steps. Begin, compute matrix and its factorization, expensive. Solve using pinned coordinates, cheap. And end, clean up. Cool. Average area for all charts. Flushing. Okay. All right, here we are in Blender/Blender. Wait, what? No, Blender/source/Blender/BMesh. Okay. We've got internal operators, test tools. Let's look at bmesh.h and bmesh tools. Okay. BMesh is a non-manifold boundary representation designed to support advanced editing operations. BMesh stores topology in 4 main element structures. Faces are in BM face, loops are in BM loop, edges are in BM edge, and vertices are in BM vert. Each element, such as a vertex, edge, face, or loop, in a mesh has an associated bit field called header flag. BM header flags should never be read or written to by BMesh operators. Access to header flags is done with BM elem flag functions. Faces in BMesh are stored the circular linked list of loops. Loops store per face vertex data, among other things outlined later in the document, and define the face boundary. Loops can be thought of as a face corner, since faces don't reference verts or edges directly. Each loop connects the face to one of its corner vertices. Got loop pointers. There are situations where you need two-sided faces, be a face, 2 vertices. This is supported by BMesh. Note that such faces should only be used as intermediary steps, not end up in the final mesh. Edges and vertices are primitive structures. Yeah, this is cool. I'm not going to read this whole file because there's a huge amount of stuff here, but it really seems like they know what they're doing. This seems like they at least that they've thought it through. I assume that they know what they're doing because they're kind of giving off that vibe, but they've definitely thought about things. Utility functions that operate directly on the BMesh. You can beautify it. You can decimate it. Yeah, this is cool. I've heard some of these terms like decimate used by Blender people. BlendLib. We've got allocators, arrays, array utils, A star. I'm going to guess is A star search, bitmap, BlendLib, boxpack, buffer, compiler compatibility, I suppose, compiler type check, convex hull, 2D. Let's look at the actual implementations. Actually, this is some classic geometry stuff, and we've got tests. I don't know if I've been missing tests in other directories, but nice to see tests in these directories. Yeah. Look at heap tests. Yeah, real unit tests. That's super nice to see. All right, intern. What did I want to do? I wanted to look at A star, I think. a star.c, and maybe convex hull 2D. Oh, Delaney. Matrix. Do we have quaternions? We have quaternions. Maybe I'll take a quick quad. We have Quadric. Quadric. Okay. Let's see. Here we are in A star. A star node init. Star node link add. A star solution init. Seems like mostly bookkeeping solution clear. Graph init. Graph solve. This is probably where the meat is. Yeah, this looks like a good graph algorithm implementation. I'm not going to read through it, but looks like it's checking node indices, keeping track of some bookkeeping, and we've got a big loop. While BLI heap simple is empty, while it's not empty, we're going to get a pointer as int and do some stuff with it to check if we're testing. We'll do some other stuff. Cool. All right. So that seems to be in Haystar search implementation. Here's convex hull 2D. Copyright 2001 by Subsurface. Users of the code must verify correctness for their application. This is, they've, I guess, used somebody else's implementation, which generally seems like a good idea. There's a good implementation. Makes all right. So that's convex hull algorithm. Delaney 2D. Define a templated 2D arrangement of vertices, edges, faces. Sim edge data structure is the basis for a structure that allows easy traversal to neighboring, by topology, geometric entries. Cool. So this should be just Delaney triangulation, right? DDT arrangement. Add diagonal. Connect vertices. Delete edges. Yeah. So what can we do with a quadric? A quadric from plane. How are we going to get a quadric from a plane? We're going to multiply the dot product. We're multiplying a vector element by element and assigning that to whatever Q is. Q is a quadric. This seems to be like a dot product. This is, who knows? I don't recognize this off the top of my head. V0 by V1. Oh, we're just filling out, I guess, the rest of it. Matrix. Okay. Quadric to tensor M3 inverse. Inline inverse matrix creation, equivalent of quadric to tensor M3, invert M3 DB. Okay. Quadric evaluate. We can evaluate a quadric on a, I guess, three-dimensional vector. What do you mean by quadric? I'm wondering if it means quadratic form. Let me see what Wikipedia tells me about quadric. A quadric or quadric surface, generalization of a conic section. Yeah, it's a hypersurface of dimension D. Can you evaluate one? In coordinates, general quadric is thus defined as by the algebraic equation. I'm going to sum over some stuff. Oh, is Q a quadratic form? Where's Q defined? Q is a D plus 1 cross D plus 1 matrix, and P is a D plus 1 dimensional row vector, and R is a scalar. It can be taken over the real numbers. The quadric is an affine algebraic variety. Yeah. In real projective space, by Sylvester's law of inertia, a non-singular quadratic form P of x may be put into the normal form P of x equal to this thing by means of a suitable projective transformation. Projective quadric is usually defined by starting with a quadratic form on a vector space. Yeah, okay, that was basically my So maybe that's what it means by evaluating a quadric, that you're evaluating like you can define a circle with an equation, right? But you don't really evaluate a circle. You don't evaluate an ellipse usually. I'm not sure if it means that or if it's doing like evaluation of the quadratic form. Okay, so what are you going to pass in? You're going to pass in a point to a quadric. You're going to pass in a vector of a three-dimensional vector of doubles, I guess. And v00 is going to be, oh, okay, we're assigning, wait, what's going on here? Doing lots of assignments? Yeah, okay, we're assigning v00, v01, v02, v11, and v12. And then we're going to return whatever this thing is. Yeah, I'm not quite sure what's going on there, but this gives you A, B, C, D. Okay. I wonder if there are quaternions in here. Is there a search function in get T? I've got this thing I just opened and it did not seem to have a search. I can control F, but I don't think that's going to open up a search utility. Not sure. What if I just do Blender? Yeah, we do have quaternions somewhere. I just don't happen to know where they are. Okay, so here we are in Blender/blend kernel. I think I looked at this for some other reason. What can we do? We can do enum path, add-on, action, derived mesh, asset, armature, auto exec, blend file, our path. Let's look at camera because we haven't looked at anything camera related yet. Cryptomatte. Okay, Cryptomatte. I don't know the difference between HH and H, but we've got a curve. Let's look at curve. We've got curves, plural. F curves, fluid. Geometry set, pencil. Instances, lib override. Mesh iterators. Mesh mirror. Node. Object. Screen, scene. Let's look at scene. Rigid body, sure. Link wrap. Studio light. Subdiv. Subsurface. Look at subsurface. BK volume. All the implementation is going to be in the intern directory. Now that this page is loaded, let's look at what was I doing? Quaternions. Yeah, so we've got a quaternion mode. More about quaternion, but I don't know where they're defined. I don't see any quick link to the source. That's okay. All right, so we've got BKE armature here. We've got selected bones callback, a bone name set. So an armature is a collection of bones. Maybe it's the same thing as a skeleton. Turn a set of names of selected bones. Okay. On BKE camera, we've got camera add and distance, sensor fit, sensor size, camera parameters is ortho, lens, ortho scale, zoom, shift it, clip it. Camera parameters, camera view frame, fit to scene, multi-view render, camera BG. I don't know what a Cryptomatte is. I know what a mat is, and I know what crypto is. Cryptomatte is Cryptomatte session material, object, render result scene. Cryptomatte is a thing that exists generally. Cryptomatte is an open source software created by some people at PsyOp. So for the specific style of images by the software, other software working. Splash screen of Blender 2.81 as rendered image, the same seen in Cryptomatte image view. Owing to its ubiquity, integration into popular 3D graphics software, and rather easy usability, Cryptomatte became a quasi-standard in the industry. It creates an ID mat of a scene that can be used to create an example, for example, image masks for simple or multiple objects in the scene. The ID mat has a very distinctive look and itself is sometimes referred to as Cryptomatte. These Cryptomatte images are in general very colorful, assigning to each object or material a different random color. Okay, so it's assigning different colors to the different objects, I guess, so you can mask them, perhaps. Cryptomatte. BKA curve. We've got a curve cache and not stuff, not su, not SU, not SV. Are these for knots? Herbs. Freeze edit curve entirely. That's a function. Here's curve stuff. Curve material, smooth flag set, center bounds, active vertex for curve. Okay, NURBS is some curve stuff. I don't quite remember, but it's like curve modeling, standard curve modeling. Make curve. We want to make a curve. We've got to give it a NURB, a coordinate array, a tilt array, a radius array, weight, and calculate the length. Let's look up NURB. The non-uniform rational B-spline, a mathematical model using basis splines or B-splines that is common to computer graphics for representing curves and surfaces. Here's a NURBS curve. I guess you have these linear segments, and you tell it maybe where the vertices are, and there's some sort of curve is interpolated between them. How that's done, I don't know. Here's a flat spline. A physical manifestation of the spline as a mathematical concept. Cool. And here's Blender BKE node. Not very important, but the stack solver likes to know a maximum. We've got a bunch of structs: data reader, blend expander, material, pointer RNA, scene, space node, node tree exec, node socket, node type definitions, compact definition of a node socket, node compositor operation function, node declare dynamic function, node gather add operations function. We've got a B node socket type, defines the appearance and behavior of a socket in the UI. UI stuff for nodes, I suppose. B node type defines a node type. Initial attributes and constants for a node, as well as callback functions implementing the node behavior. Cool. Pretty complicated. That's good because it has lots of functionality, but it's not. So node, presumably we're going to build a graph out of the node. Standard thing does. The nodes have to have different types because I don't know what counts as a node, but you might have a scene be one node and then an asset be another node, and that asset might have subnodes. There are lots of different types that a node could have, and then you need to have kind of generic enough behavior for all of those types to do their thing. So we've got mat, group, converter, distort, pattern. So this is, I assume this is just kind of setting up all of that stuff. These are generic API trees. So B node tree type, star entry type find, our ID name, entry type add, entry type relink. We've got helper macros for iterating over tree types. You can set tree types, set output, blend relib, sockets. Yeah, there's a lot going on in this file. Okay, so I think if you were to try to understand the Blender node system, it would be a good file that you should read. I'm not trying to deep dive into the node system, and so I'll close this out for But I think if I were to deep dive into the Blender node system, it would make sense to first have a handle on using Blender so that you know what kind of user-facing behavior they're trying to achieve with all that code. But that, I mean, that looks good. It looks like you would expect it to look in something as complicated. Okay, so BKA scene. Seems like scene is smaller than node. Not surprising. We've got some looper stuff. A scene object find, scene base iter next. Used by metaballs, return all objects, including duplies, existing in the scene, including scene sets. I'm guessing duplies are duplicates. BK scene object base flag sync from base. BK scene can be removed. See time get. Return fractional frame number, taking into account subframes and time remapping. This time value used by animation modifiers and physics evaluation. Activate a transform orientation in a 3D view based on an enum value. Return the default view, return profile. Get the video dimensions. Return the index that an orientation has within a scene's transform. Or -1 if not found. Okay, what is a rigid body? So I'm in Blend kernel / BK rigid body. Rigid body free world. Free rigid body world. All in the scene. I guess there's some concept of a rigid body world. Okay, here we go. Rigid body maybe object, world, body world, collection, dependency graph maybe, main object reports list, creator void, rigid body world, func. Set up rigid body world. So how do we create a world? So we're going to create a world and we're going to pass in a scene. We're going to add settings to it, create object, pass in the object. Here, add rigid body constraint to the specified object. I guess the constraint is a short type. Your newly set objects all have prior data. Validate some stuff, helper function. Utilities, we can add sync transform. Check sim running. I guess check if a simulation is running. Check if a rigid body is affected by the simulation. Okay. Here's BKE subsurface. We've got edges, elements, vertices, edge hash, mesh, object. Not sure what PBVH is. We can make derived from derived. I'm going to pass it in a derived mesh, a subsurface modifier data, a scene, other stuff. We're going to get back a derived mesh and calculate limit positions. Here's the struct CCG derived mesh. Start vertex. Vertex. Start vert and an edge and a base. This is, I guess, a vertex. Okay, so yeah, vertex map, edge map, and face map. Okay. All right, here we are in Blender asset system. And I guess I'm not really going to look at this. I think this is just going to be mostly like file stuff. I think all the real work is done in the other types. Storage, representation, library, service. Yeah, I'm going to skip that. Compositor. We've got tests here, which is good. Not a lot of tests, but still, some is better than none. Real-time compositor operations, nodes, and let's take a quick look at real-time. We've got algorithms, a scheduler. Let's look at algorithms and scheduler. That's really all. Parallel reduction and symmetric separable blur. What does the scheduler do? Got a type representing the ordered set of nodes defining the schedule of node execution. Okay, so it's a vector set. an ordered set. So the executed in order, I suppose, and a compute schedule. So this blur thing is going to blur the input using a horizontal and vertical separable blur passes. Blur the input using a horizontal and vertical separable blur passes, given a certain radius and filter type using the symmetric separable blur weights. The output is written to the given output result. Okay. Then we've got this parallel reduction thing. We can sum red, sum green, sum blue, sum the luminance, sum blue squared difference. Got maximum luminance. Okay. And here's depth graph. Mainly, I guess I want to know and we can query it. We've got physics. Dependency graph tracks relations between various pieces of data in a Blender file, mainly just those which make up scene data. It's used to determine the set of operations needed to ensure that all data has been correctly evaluated in response to changes. Okay, so that is the dependency graph. That's the main thing to know. But if we have a query file, I guess I'm curious how you query them. Get input scene, get evaluated scene. These are getters. Is there a query language? Object iterators. Name, DEG ID iterator. We've got iterators. Whatever this is, what is this? DEG, each independent ID component. Starts traversal from a given component of the ID, invokes callback for every other component, which is directly or indirectly dependent on the graph traversal. Raw, I'm going to skip over. I feel like I've seen enough. Kind of have a sense for how they would do drawing. Nodes, I looked at a bunch of node stuff, but this must be the deeper implementation of the actual node type. So I'm wondering if node geometry is the geometry of node, or if there's a geometry is a kind of node. Okay, take a quick look at node geometry. Register node, type geo custom group, node type and type. Entry type geometry. I think that probably means that geometry is the type. And then here we have Python. dpy python extern.h, turn run extern python.h, intern GPU math BMesh. So some mesh files. This is not Python, but this must be Python bind. This must be yeah, Python C binding is what I'm. What is GPU? GPU.py. GPU.py.c. We're going to include python.h, which I guess is probably Python C. GPU init exit. So, okay, so this is, I guess, giving Python control of the GPU. Kind of binding. Sequencer. Animation channels, clipboard, edit, effects, iterator, modifier, select, sequencer, sound. What does this do? RNA enums. Get seek base. Being viewed currently, this can be main seek base or strip seek base. Meta stack set. Open meta strip content for editing. Read and write functions for .blend file. Depth graph update function. Find a sequence with a given name. And free lookup hash data. Find a sequence. Cool. Look at anything else? Transform. Seek transform single image check. Test overlap. Seek base shuffle X. Return 0 if there wasn't base. Handle overlap. Check if selected sequence references. Transform image offset pixel space get. Image preview unit from preview. Then we've got some shader stuff I'm going to ignore. Then I'll take a quick look at simulation. We've got mass spring.h. This is really, maybe this is just example simulation. Hair volume, implicit. Hair volume. Simulating hair, like hair follicles. Volumetric hair interaction. Volumetric methods for simulation, rendering of hair. We've got this. Is it the credit? Petrovic, Henne, Anderson, Pixar technical memo. Number 06-08, Pixar Animation Studio. So what was the Disney film with hair? Tangled. When did Tangled come out? I'm guessing it was around 2008, 2010. So was the hair. Okay, so this memo seems to be maybe from 2008, detail preserving continuum simulation of straight hair, 2009. So this is the right era for people figuring out how to do hair. And then, of course, Disney Pixar comes out, movie where it's all about hair. I think that Pixar and Disney have been doing this pretty consistently. A lot of the movies kind of thematically have, they figured out how to model some sort of typically like a particle system. I think Frozen, before Frozen came out, they had to figure out how to model snow and ice very well. So before Tangled came out, figure out hair. And maybe like Moana, they had figured out how to do water really well. I think that's kind of a pattern that I've noticed. I'm sure somebody has said something about it. I'm not really sure. So how are we going to do hair? Got some sort of floor mod value, which seems to be take the value and track the floor function. I guess that's modulo the floor. The remainder, I guess, have to take the floor. Something. A hair grid vert is going to have samples, velocity, density, velocity, smooth. A hair grid is going to have hair grid vertices, res, which might be resolution, a Gmin and Gmax, cell size, hair grid index axis, hair grid offset, hair grid interpolates, interpolate. This is probably function seems like it's doing some work. Hair volume vertex grid forces. Smooth fac, pressure fac, min pressure, F, df, dx. I don't know what F is, but we're going to differentiate it with respect to X and differentiate it with respect to V. Not sure what V is. Oh, okay. These are X and V are these floats that we passed in. What is F? This thing. Okay. And we're going to pass in the derivatives as matrices. It's going to be like a total derivative. And we don't compute them on the fly. You somehow have to know what they are. And then we've got some interpolation stuff where we pass in the gradient. Now we're going to get as void. Wait, are we computing? Wait, this is void. So what's the output parameter? Maybe we don't pass these in. Maybe we do compute them. So sub M3 dv dftv eval grad I m mol M3 FL df dv smooth fac. I don't know. Hair grid interpolate. I guess this is probably gradient. If grade length is bigger than 0.0f, so positive, we're going to multiply some stuff. All, I guess, vector, maybe a three-dimensional vector float, multiplication, grade length, gradient. Maybe scale the gradient by the gradient length. M add. Maybe we are computing the df dv and df dv. df dx and So these are both DFDV, and then 0M3 being called on DFDX. And where else is DFDX being used? FDX. What is 0M3 going to do? Seems like we're just zeroing matrix. I'm not sure. Not clear what the out parameters of those functions are. I'm not sure I want to track them down. But I will look up, see if they have 0M3, if that's defined here. If velocity gradient, we're going to 0M3 velocity gradient. Okay, something about gradients. I still don't think I can search this, right? Oh, there is a Blender. Let's see. Blender GitHub. I think there is a GitHub mirror. Maybe I can search that one. 0_M3. 0_M. Nothing. What if I just search the internet? Functions void. Okay. Seems to actually be from Blender. Definition at 36 above blah. 0M3. We're going to memset 0 3 times 3 size of float. Does seem like zeroing. What was the other question I had? So what's the out parameter? Air grid offset. Vertex grid force. Whatever this is. Warning, expressing grid effects on velocity as a force is not very stable due to discontinuities, interpolated values. Better use hybrid approaches such as described in detail preserving continuum simulation of Adams and Cell 2009. These are not taken as references. I guess the hair grid is the okay. Well, we'll leave that at that. And then here we've got implicit blender.c. We've got struct cloth. Cloth is interesting, I think, also to model. Create long vector, create float. Why is it called implicit? Implicit solver. I guess it solves equations implicit. Long float, create LF vector. I guess long float vector, dot LF vector, dot product for big vector. By big, does it mean like sparse? Sparse matrix, sparse symmetric, big matrix. Vector, we've got force vectors, force Jacobians, mass, spring, clear, force, implicit data. All right, so this is where some of the math is. We're doing some kind of physics. All right, so that was fun. Blender seems pretty mature as a code base. They're doing, seems closer to some professional code bases. I think it's got a lot of tests. Not quite as many comments as I would have preferred, but it seems like they've documented stuff elsewhere. And they produce a product that people seem to really like. I think that's really great. So that's all for me. Thanks for watching.